In this video, we're going to talk about acid-base titration. So if you have an acid solution and you want to neutralize it, that is to say, get rid of the acidic protons, you react them with a base. Now if you add too much base, now you have a basic solution. If you don't add enough base, it's still acidic. So titration is the procedure where we try to find the exact amounts of acid and base where they exactly neutralize each other. And there's no H plus or basic, let's say hydroxide in this case. And so the way the procedure is typically done is you take a very exactly known volume of the solution that you know or searching for the molarity of. So you either have to know this molarity or this one. And so in this example, we know how much we have in the flask because we used a 10 milliliter pipette to measure exactly 10 mils in here, but we don't know the molarity. So we have a base here, which is sodium hydroxide, and we know its molarity is 0.225 moles per liter. Okay, and so one thing you can do is you can either convert milliliters to liters and work with moles. Some people actually say, if I'm using milliliters, I know I'm going to get millimoles when I multiply volume times molarity. But that's the key tool. The volume in liters times the molarity is equal to the number of moles. This is true for the acid solution. So the volume of the acid times the molarity of the acid is going to give me the number of moles of acid. And the volume of the base times the molarity of the base is going to be the number of moles of base. And if I know from the balanced reaction how many moles of acid will react with how many moles of base, then I can accordingly calculate everything out. Okay, so let's take this a step at a time. We need to write down the chemical reaction. And so sodium hydroxide plus hydrochloric acid is going to produce water plus table salt. And this is all 1-to-1, so I know that the number of moles of sodium hydroxide has to be exactly equal to the number of moles of HCl, which makes our calculation a lot easier. All right, so of the two solutions, which one do we know both V and M for? Well, it's the hydroxide. So we're going to calculate the volume of hydroxide times the molarity of the hydroxide. So .0185 times 0.225, and it's 4.16 times, I'm going to go ahead and do it times the whole thing. Since I have 4.1625 times 10 minus 3 moles of base, this reaction tells me I must have exactly that many moles of acid at the neutralization. So now that's moles of HCl. That's going to equal the volume of the acid times the molarity of the acid. The volume is 0.01000 liters. The molarity is what we're solving for. And so it turns out the molarity of the acid is going to be 4.16 times 10 to the minus 1, because that's all that dividing by 0.01 is going to do is change the power 10 to minus 1, or 0.416 molar. All right, now does that make sense? Since I have a smaller volume of acid than I do base, then it must be more concentrated than the base. So the molarity is going to be greater than 0.225, and since the volume is about half, the concentration must be about double, so this checks out.